In this exercise, we are required to prove that this correspondence here is an equivalence relation. For that, we need to check that it satisfies the three properties for an equivalence relation, meaning it is reflexive, symmetric, and transitive, right? So first, reflexivity. Reflexivity means that x, y has to be related with xy, which means that this has to be true, which is obviously true. Symmetric. Symmetric means that if this is true, x1, y1, x2, y2 is true, then x2, y2, x1, y1 is also true. Okay, but this is equivalent to x1, y1 equal to x2, y2, and this is equivalent to x2, y2 equal to x1, y1, and obviously this is the same equation. So of course this one means this and this at the same time, so this is symmetric. Finally, transitive means that if you have x1, y1 related to x2, y2, which means this, according to the definition, and x2, y2 related to x3, y3, which by the definition means this, then you must have x1, y1 related to x3, y3, which is true because if this is equal to this and this is equal to this, since these are equal, then these are equal, so this is true. So yes, it's also transitive. So it is an equivalence relation. And then what we have to do is to obtain the quotient set, which means we have to take the R2 and find the equivalence classes with respect to the equivalence relation R that we have just defined. Okay, so what is the equivalence class of, say, the pair xy? What's going to be all the elements in R2 such that the multiplication x and y is equal to c for some c, some c in R, any c in R, right? Okay, so for all elements or points in the plane for which the product is a constant, they are all in the same equivalence class. Geometrically, this corresponds to this this picture. Okay, it's represented by these hyperbolas here. All right. So all points in this hyperbola, this and this, of course, are because the product here is the same as the product here, so this is also c equal to a, right? So this and this hyperbola corresponds to c equal to a. This and this corresponds to c equal to 4, etc. And the negative ones are here. Also the axis, right? So the vertical axis and the horizontal axis are the sets corresponding to c equal to 0, right? Because if you multiply x and y and it gives you zeros, because either x or y or both are 0. So these are sets corresponding to c equal to 0. So these are the equivalence classes of this relation.